So good evening, everyone, and a very warm welcome to all of you to the webinar on Future of Data Science and Machine Learning in Industry and Academia. The speaker of this webinar, Karan Wanchoo, is currently a graduate student at University of Pennsylvania in the Electrical Engineering Department, pursuing research in natural language processing and computer vision. His ongoing research involves building systems that facilitate user interaction using natural language, as well as performing large-scale analysis to discover new behavioral and psychological factors of health and well-being manifested through natural language. Prior to enrolling in the master's program at Penn, Karan had worked for 5 years with several of the world's leading technology, telecom, retail, and manufacturing leaders from different geographies, specializing in building analytical and machine learning solutions. All the questions will be taken up at the end of the webinar. You can also write your questions in the chat box down there. Handing over to Karan now.
Yeah, thanks, Meg. I would like to warm welcome everybody to this webinar. I'm in fact humbled and honored to be speaking today at this platform. So without having any further ado, I think we can begin. Just a few logistical advices. Like I would like to make this discussion very interactive, but since the crowd is large, I would appreciate if you can write your answers to my questions during the presentation in the chat window if you want to. I will take all the questions in the end, so maybe you would like to hold on to your questions for a while. Okay, so let me share my screen. Meg, is it visible?
Yeah, it's visible.
Awesome. Okay, well, welcome to the webinar or discussion forum for today's topic, which is what is the future of data science and machine learning in industry and academia both? And I'm Karan Wanchoo. I'm currently a graduate student at University of Pennsylvania. I was formerly an undergrad student at Punjab Engineering College long back. I began in 2011. And I believe that majority of the audience today is from PEC as well. So agenda for today looks like I'll give a brief intro about myself, which I think Mehak has already covered. Then we'll walk through what all are the current and cutting edge requirements that revolve around data science, all 4 aspects of it that are currently in operation in industry, across geographies, across industries, across verticals. We'll do a single use case to understand them better. Then I would like to touch upon what is going on at different research facilities or universities in academia, again, with the center of focus being machine learning, analytics, and data science. Okay. All right, I think somebody was annotating. Let me revoke the, if I can. Meg, can you see if you can revoke the annotation options? It is fun to be working with undergrad students. Okay, never mind. I will trust that all of you would let me present it as it is, right? And if you would like, then I would give you the option to scribble on the canvas in the end. Okay, let's keep it that way. So my name is Karan Wanchoo. I was born and brought up in Chandigarh. I did my bachelor's in electrical engineering at PEC long back. I'm a fossil now. And after that, I got to work with some Fortune 100, 500 clients by working in two big consulting firms. I was a part of the applied intelligence teams in both the companies, and I got to work with clients from retail, technology, manufacturing, healthcare, telecom, all different divisions and verticals. And currently, I'm pursuing my master's in electrical engineering. My specialization is information and decision systems, which is AI and data science. I'll be graduating in the semester in spring, right? And my current research projects have revolved around social media analytics, vision and language navigation, which is related to computer vision, natural language, and robotics at the intersection of all three. And I also did one healthcare project, which involved crunching some healthcare data related to medical health conditions and COVID-19 and give out the relevant classification. Okay. So Industry X.0. Well, currently, I think we are a part of Industry 4.0, which entails all the automation, cloud computing, data science, all of that. But I say X.0 because we would like to discuss or at least brainstorm what the future might look like. In order to understand what the future will look like, we need to understand what is currently trending or currently what is in demand, right? An application. So I see industry revolving around these four pillars, which is data-driven transformation, which every firm is trying to apply irrespective of industry. That is industry. Actually, all four of them are industry agnostic, right? Even if you are a part of an energy industry or you're a part of retail or technology, it doesn't matter, because these are all tools that will help you flourish your outcome, enhance your outcome. So data-driven transformation, then we have AI automation, we have responsible and reliable AI, and then we would have cloud services. So what would data-driven transformation be? I mean, conventionally, when you were a retailer, you would rely on your intuitions of how the business performs, how seasonally products fluctuate. You would probably have to live on your intuition and then manage your inventory operations. There were no tools to maybe forecast your demand so that you can optimize your supply. But right now, the people in the last, like say, a decade have started garnering their own data. They're storing their own data. They're purchasing third-party data. So there's, in fact, a lot of data that is revolving. But how do you use that? How do you leverage it? And in what ways can you basically, okay, live transcription. I don't think that's required. Anyway, so how can you basically drive transformation in a firm? You would first want to basically align your business goals and your data strategy. Data comes at a huge cost, right? It's not inexpensive. So you would want to have your business goals enlisted. You would try to then take that data and apply different models and then take out insights from that data and patterns, and then see again how it can solve your current business problem, or maybe you could use it to tap new avenues, new domains, like you want to expand your business, you want to enter a new market in a new geography. All of that becomes more sound. That decision making becomes more sound if you have more data to supplement your decision making. All right, then what comes in AI automation? Actually, why do we need? These are all attributes or applications of these four pillars. So why would you need AI automation? Well, you would want to make your human resource more productive by letting them do things they're more skilled at, and taking out the chunk that is more redundant or repetitive. That's where AI automation comes into play. But it does make businesses more agile and productive, but there is also an interplay of governance, culture, and leadership. You cannot simply say today that so and so part of your process chain will be completely automated. This has to flow through the employees, right? So that is a very important aspect of AI automation. That is somewhat linked to responsible and reliable AI, because if you're doing data-driven transformation, you are doing AI automation. How do you ensure that the data you have is not biased, is not skewed? I'll talk about different types of biases in data. And if the predictions you get, the classifications you get out of your AI models, or whether they are reliable or not, right? Also, you want your entire ecosystem to be transparent and explainable, because this is something that has recently caught the attention of people. So not everyone from every geography or every business vertical is familiar with how data crunching, prediction, AI, how all of these jargons or buzzwords they work, right? So that was about making AI responsible and reliable. Finally, cloud services. You must have heard about the word cloud computing, right? Please don't scribble my canvas. Right? If you could undo that, it's a little distracting. Thank you. Well, cloud services are more oriented around, there are three basic classifications, like infrastructure as a service, platform as a service, software as a service, right? All of them have different meanings. Then there are public and private clouds. Basically, why would you need a cloud-based environment? The data that is flowing right now is dynamic and high velocity, right? You want to make just-in-time predictions for your business goal. The amount, so the data usually goes around in gigabytes that flows every minute or every hour. You can't run models on your local machines, so you need cloud-based services like MS Azure, you have GCP, Google Cloud Platform, AWS, KeyPies for healthcare, that's a private cloud. Google SAP and Amazon VMware services, AVS, are hybrid clouds. They work on a tenancy model. What is a tenancy model? So like a tenant, you rent out these facilities, and then you make use of them. You run your models, you put your data on databases on the cloud. And when you are done, basically you stop paying the rent, right? So that's a multi-tenancy model. All right. Okay. Now let's move on to a hypothetical use case. We'll use one use case to understand how all of these four pillars come into play. All right. So it's a very basic ask. Ask means the objective or the business goal. Like you are in a company, and what would you like to do if given you have data and some AI? You would basically want to enhance your customer experience, right? This is again industry agnostic demand. Even if you're a bank or if you are a retailer, you would like to give the best possible customer experience. So let's say we are working with a telecom company that operates globally and wants to enhance the user experience, let's say by predicting the future customer needs. With customer needs, I mean like when a customer calls a telecom operator with some grievance or with some demand, right? So can data and AI help you predict well in advance what a particular customer would be calling me, let's say 2 months from now? Okay. All right. I mean, I would share my potential AI driven approach, which I think how can be utilized. But if there are any suggestions, you guys can write it in the chat box. If there are any relevant suggestions, maybe you can let me know, because I'm sharing my screen. I'll give you 1 minute to think. Okay, never mind. I mean, I thought that people were artistic, so they might be innovative too. Okay, let's say, so let's assume that the telecom company has access to its own user data, which basically comes down to your past, all for all customers, your past customer queries, what they have been, what are the complaints have been, usage patterns, active services, and this is not the end. Like there are so many different metrics that you can take into account. There'll be demographics, and then there'll be you can connect data from their roaming data from their phones and all of that, and you can easily come down to a structured database of, let's say, 1 million data points. That's very easy, honestly. I mean, Google has over 1 million data points on you running right now every second. How about you also take some historical voice data from customers, and this is not stealing their day-to-day voice data by turning on their mics. No, when they have called you in the past with their grievances or queries, you basically record those calls, right? So could you take that too, apart from the static data points on every customer, and then can you extract information from a 5-minute call recording? Well, I believe, I know that, yes, you can. So you basically would put in place something that is called as a speech recognition AI that would take in your voice. This is something which today's bots work on, like Alexa, Google Home, all of these, right? And after that, you would extract more data, like what was the query, what was the entity, what was the how can the customer's behavior be termed as, what was the need, emotional valence. Valence is how emotional the person was. This is a psychological term. What was the sentiment? And you can take all these data points and profile your customers in whichever way you want, right? Depending on your business goal. Now, for every customer, you have specific static data points and some very valuable data that has come out of their own dynamic experience. You take all of this and you could put this in a big AI prediction engine, and you could predict two things. You can predict the future query of a customer. So for that, you need to enlist like 3 or 4 or 5 or 10 major buckets in which your queries fall. Like person was calling for some value-added service, person was calling for difficulties in network, person was calling for roaming services. You would predict these. And also then you would, if you are a very ambitious company, you would want to route the customers, the profile customers, to most relevant channels to get the query resolved. Please note, there is no human intervention happening anywhere. If you want to route a customer to a particular channel, you basically predict. So they would predict, if Karan is going to call me in 2 months, because basis on my historical usage pattern, he's going to call me. If he's traveling in the next 2 months, he will call me for some network issues, because the possible geographies he can go to are this, and this, and their collaboration with other network local providers is not so good. So they would, as soon as I land there, they would start recommending me what all I can do to make my network better. And then, like, going a step further, you could do the last step by routing the customers to most relevant channels. You can basically introduce another chat bot that would talk to the customer. So you see, a lot of things have happened here. And now let me tell you what was the data-driven part. Like if you think what I mean, all of this was data driven, right? Your static data points, your voice data. So this was a data driven transformation, uh, how it took place. Also, if you guys can think like what more value can be added here, and what the future could entail. So I mean, the sky is the limit. The more innovative you get, the more brainstorming you do, you can actually uh, see how it can be made more robust, more scalable, right? Okay. Okay. Now, what part of this is AI automation, right? All of this end to end is basically intelligent automation. I hope everyone agrees with me on that. Let me actually click on chat. All right, great. Can you think of the impact of this data and AI-driven transformation? Okay, we'll come back to it. What part of this? Oh, right, sorry. So could data bias exist as a part of it being responsible and reliable AI? Could there be a bias in the data at any point in the service life cycle? So data bias will exist where data is, where all is your data coming from. Your data is coming from your static data points, your voice data, and whatever you use to profile your customers, right? What are different types of data bias? Like these are a few that are different. Like there's a term being coined every now and then, but these are the more popular ones, more relevant ones. You have your sample or selection bias. It means your training data, when you're training the model, it is skewed on some very specific customer queries. It means you let's say you have 100 data points, 80 of them correspond to only those customers that report network issues, and the remaining 20 are split between other types of queries that you want to predict. This will be a very biased model. You would always be predicting network issues for every customer, right? Racial bias is more like when you have demographics. Let's say you have geographical data, and it turns out that you stored the data for only Europe or Asia Pacific geographies. And you're trying to, because you operate globally, you're trying to predict something for the American region, your model will fail, right? There's a gender bias. There were unequal samples of the genders in your data, right? They have to be balanced 50-50% and so on. There's a recall bias, like you label two different data samples as the same possible query. So like you have two different customers who who are more prone to ask for two different queries, but during training, when you are annotating your data, you give them the same query label, right? So this will skew your results. All right, and how would you basically implement the reliable and responsible AI? Well, it's not only about algorithmic fairness or compliance, right? You need to have the right tools, frameworks, and methods, and you need to give it ample amount of testing and evaluation. And this is where you will actually figure out what all bias in the data was, how biased or your skewed your model is. If the results make sense or not, then you align them with your business intuition, right? Because again, this is a tool. It is not there to completely replace human intelligence as of now, right? Okay, and now finally, if we think of cloud services, like what part of the entire service life cycle would you term as AI automation? This was again end-to-end cloud-based service. You cannot run any part of this life cycle on a local machine, right? You have to put huge amounts of data on cloud. You have to put your algorithms on cloud. You have to train them on cloud, and you have to take the predictions on cloud. And then finally, you will uh, plug in, let's say, the chatbot I was talking about to execute your strategy that will again be operated on the cloud. So can you name a few cloud-based services? Well, I told you like AWS, GCP, any of them, public-private clouds. And for servers, like infrastructure as a service, if the company is big enough, it has the capital, they would want to have their own physical servers, right? So what are your key takeaways as students, which I think are make up the majority of the audience today? For data-driven transformation, you need to stay abreast with the industry. So you need to read more about use cases and how you can do that. You can go to IEEE. You can read IEEE articles. There is MIT Technology Review, Harvard Business Review, Wall Street Journal, TechCrunch. Big four companies publish their reports, so you can know what is going on in the industry currently. You can read research papers. Why do you want to do that? If you are not abreast with what is going on currently, you cannot know where the gap lies in the innovation, and wherever the gap lies, that basically is the future. Yeah, automation, for that, I would recommend you would want some industry exposure, like maybe through internships. You can do big data analytics or some automation related roles if you could find that as a part of your internships. That would be very helpful for your own self. And then there are some university programs. You could try to tap those. You can do Kaggle competitions too. They are pretty reasonable. And cloud services, yeah. If you're involved in any industry project, I think you will these days get a flavor of Azure, AWS. Well, as data scientists, you first need to take care about bias in your data and machine learning models, and not worry so much about how it will be implemented. That's more or less part of the role of the leadership of the firm. Given that you guys are very young, you would want to first see how you can remove bias from the data so that your models are more robust and reliable. Okay, so now we can touch upon what's the current research happening at different research institutions. I want to say that academia and industry are not much different. Industry makes you familiar with the demand that is required out there, and academia tries to come up with the most efficient research solution for the industry. So they go hand in hand. There's not significant difference in how they operate. So, but I would like to touch upon like we showed a use case for the industry setting. I would touch upon a few recent research papers that talk about either deep learning techniques, computational linguistics, which is natural language processing, robotics and computer vision, and human computer interaction. I'm not sure if you guys have heard about this, but this is quite trending these days, and it is a very very broad concept, and it does not only entail AI or data science. So deep learning, well, I think the current research or something that is more prevalent or prominent these days is reinforcement learning, making your models more robust towards adversarial attacks. What are adversarial attacks? Like if you fit your model, this could be interesting. You fit a model on let's say person recognition to identify whether the person is male or female. You introduce some statistical noise into the system, which your model was not prepared to take. And then your predictions go completely wrong. You predict a male as maybe a female, or if it was object recognition, you predict table as a chair, right? So currently there are researches going on to make models more robust towards adversarial attacks. This is what an adversarial attack means. Then these basically are being applied across industry. This is industry agnostic, life sciences, psychology, renewable energy, automobiles, business. Everything is leveraging deep learning models right now, right? Researchers are also working on generalization of algorithms so that they can work on different types of data distributions and not be restricted to just one. Then we have computational linguistics. Well, you must have heard about natural language generation, GPT-2, GPT-3. That is something people are working on. Common sense reasoning, I'll talk about this after the slide. We have social media analytics going on. I was a part of a research group that was doing that. Open domain question answering systems. This involves robots and chatbots both. Robotics and vision, well, we have vision language navigation systems in which there's an agent or a robot, and you try to pass on instructions to it through text, and the agent is able to perform the task in unfamiliar environments, like a house. Like you go and buy a robot, and then you text the robot like, could you get me a glass of water down the hallway by turning right into the kitchen? Is the machine going to understand the text? The machine only understands numbers, right? So there's some research going on that. And then there's teleimmersion, localization, drone navigation also comes into this. HCI, human-computer interaction. When you interact with computers, your phone, all devices, that all falls into HCI, human-computer interaction, right? And social computing, crowdsourcing systems are currently the focus of this umbrella term. UI, UX design is a very important part of HCI that is trending. So if you're a computer scientist, you could be a part of the HCI group by just being UI designers, right? Because you need an interface for the human to interact with the machine. Okay, let's quickly touch upon some deep learning use cases, right? And I've tried to make them exclusive from NLP and vision, because deep learning again is an umbrella term that is a superset of which also has NLP, robotics, and vision. All of you watch Netflix. How do you think the Netflix people recommend you what to watch next? There's a lot of customer profiling going on at the back end, but what all data do you think they use? If you want to know, well, there's this paper. I'll share the presentation with Mehak, and then you can reach out to her. There are hyperlinks in these headings, and you can click on them to view the entire paper. Basically, they try to put in different deep learning models and take in customer data, such as your past ratings, the ratings you have given to the shows or the movies that you watch, and what other customers have given. Then they try to profile or group customers together, the users. Then they try to recommend them basis on basis what the AI gives as a prediction, right? Well, then you have some work going on deep reinforcement learning for target tracking. So these are all agents or robots. In reinforcement learning, you have the concept of learning a policy, and you give either a reward to the agent or a penalty, and that's how it learns. So it is not supervised, in which you have a static data and then basis on the training data to predict. Here, the agent learns by rewards and penalties, right? So this is again This is again one hot topic that uh, is catching the eye of researchers. Healthcare monitoring systems, right? You wear an Apple Watch, you have different wearables, Fitbit. All of that data goes to the cloud. Your heart rate, pulse rate, body temperature, breathing patterns, sleep patterns, all of these are being currently utilized and put in a big database, and there's customer profiling going on there too. And then there is a recommendation coming out like maybe you're sick basis on your breathing pattern. The AI can predict that. And then they can also recommend you have not been following up with your doctor for your past illness. Here is how your current body statistics look like. And we think that the AI thinks that you need to uh, visit your, let's say, ENT specialist ASAP, right? And this paper particularly is on heart diseases, right? How to predict heart diseases. Okay, moving on to linguistics. This is kind of my favorite forte. On the left, you see something called as social bias frames. Now, what are those? So let's say there's a statement that says we shouldn't lower our standards just to hire more women. Can you classify this like was it intentional? Well, most probably. Was it offensive? Yes, it was. Was it lewd? No, it wasn't lewd, but it was offensive. Was the group referenced, like women as a whole? Yes. You see? Now, why would you want to do such an analysis? What would you achieve out of it? You would want to take out, like, summarize toxicity levels in discussions happening. You would want to summarize the stereotypes in discussions happening. And trust me, there are so many discussions on Twitter and Reddit in different forums that are happening that demand some urgent filtering or at least identification, especially during elections and campaigns. They can sway the vote bank completely, and so you need to figure out how social bias works. This can be done using natural language processing. Feel free to read this paper. Is there fairness? Again, now in as I was talking about data bias, let's say you collected some linguistic data from Reddit and Twitter, but was it representative of all the demographics or all the communities that you have, like all the genders or locations or countries, like you see there? If it wasn't, then there's a bias in your data, and that the prediction will not be truthful and reliable. And hence, this paper talks about, had this data not been biased, then the model results are very different. So if you want to predict depression using statements, and there's a lot of work going on in prediction of mental and physical health through social media conversations. But if your social media conversations are skewed, then your predictions will also be skewed, right? Well, common sense reasoning, which we saw a few slides back, it's about if you are generating text through machines, it should also make sense, right? For example, a human annotates a statement like, a dog leaps to catch a thrown frisbee. Okay, fair enough. The dog catches the frisbee when the boy throws it. But what does GPT-2 give you? A dog throws a frisbee at a football player. Is that possible? No, a dog can catch it through its teeth, but can it throw? No. So it lacks common sense, right? Then you have another model that says a dog throws a frisbee and a dog catches. These are all the bottom four are all machine generated text, but there's research going on to make them so that they make sense. They can make some sense out of it, right? And that is generative common sense reasoning. Coming to robotics and CV, well, I've talked about vision language systems, like you give a written instruction and the agent is able to assimilate it and perform the required task, right? So you see an instruction that was given: walk to the right around the fireplace through the doorway and turn right and wait in the hallway by the pocket door. There's research going on how to make it more accurate, and trust me, there's a lot of scope in this. No, not much research has been done in the last few years. Sorry. You can also do map prediction using instructions, like if the agent is smart enough to think for himself or herself that if I'm in the kitchen, then I should be seeing a dining table, a gas stove, a sink. So if the agent recognizes the object and feels that, oh, this doesn't seem right, I'm probably in the bathroom, right? That's what makes it actually intelligent. The whole concept of having a robot and self sufficient. So there's work going on that. Then you have video prediction without annotation. Can, like, someone say, where can this be used? I mean, you can predict what's going on in a scene in a video, but can you give a more relevant example where this can be placed? What is a video? Video is a set of frames, right? 60 frames per second is usually how you process or render a video these days. So if I give you those 60 frames and you recognize what is happening in that scene, you can probably use it in a car like Tesla to predict, to first analyze what is happening every microsecond. And if someone is crossing the road, then you should stop. So for actions to take place, you need to understand, the self-driven car needs to understand what is going on in its environment, right? So this research helps you there. I added a slightly, I'm not sure if it's gonna be funny to you guys or not, but visual question answering is, which is quite trending. So you see a cat, right? So the AI recognizes it's a cat, but when you ask the AI, does the cat look happy? The A corresponds to the human answer. Model answers, there are 3 different models that were tried in this paper. And the model says, no, no, no. In visual question answering, right? If you added some adversarial noise to your model, that is ADVQA, now if you ask, like, how many cartoon drawings are present on the cat's tie, the answer is 4. If you would zoom in, then you would see. But the 3 different models, all of them come out with incorrect predictions. One of them says there's just 1 drawing or 2. So VQA is another very trending topic that has demanded some research, right? Finally, human-computer interaction. Okay, I tried to make this interesting. Some HCI applications could not be so appealing to computer scientists, but I've tried to pick and choose these few. Okay, so the first one is an AI-based request augmentation to increase crowdsourcing participation. What is crowdsourcing? You create a data set, but then in order to train a model, you need to give in labels. Now, what if you have 10,000 images? You as a researcher or your supervisor are not going to spend 6 months annotating them. Annotation means giving the true labels, the ground truth. You will not spend 6 months annotating those 10,000 images, right? So you outsource this to the crowd. Very popular crowdsourcing tool is Amazon Mechanical Turk. You pay the people, you pay the crowd on some like hourly or daily basis, and then they annotate it for you. And then you get those annotated data back, and then you use it. There's a research going on to understand if these crowdsourced annotations could be boring to the crowd and not appealing, right? And if you see, they use AI to make these questions more interesting, right? Like the ones you see highlighted, like that's a great outfit. Where is this place? So the original question, the intent was to ask, where is this place? That someone from the crowd can label it if it's a garden or whatever. Just to make it more appealing, they used natural language generation and put these prefixes over the actual questions, right? There is another paper that's called Story Coder. They have created an app for I think for storytelling, right? Where the users they create and listen to stories as well as perform some computational thinking games. So it is pretty interactive. I think it's for kids and adults both. But all of this works on AI. Like the stories are generated in real time. The games are generated and evaluated in real time by the AI. There is no human intervention going on. This is also part of HCI. Finally, there is some automatic generation of two-level makeup tutorials. You had a video, you had the transcript, you use AI to merge them together, and it finds out on its own, like frame 14 corresponds to this transcription, frame 15 corresponds to this transcription. This is all automated. It intelligently identifies what's happening in the video versus what's happening in the text and how they can be put up together, right? So this is more or less about all these four research areas related to academia. Again, both of them are very closely related to each other, industry and academia. They work hand in hand. I've tried to put out some examples that are appealing, and you guys as undergrads could work on these, like, but you need to first upskill yourself to make yourself familiar with cloud-based technologies, programming languages, databases, data structures, statistics, machine learning algorithms. And eventually, like when you are ready to graduate, you would have the right skill set to either apply to industry or to academia, right? Okay, now I can take questions. I'll minimize my screen. So I would let's see how there were a few questions in the Google form that you guys had filled. I think Meg can go through those. Also, if there are any questions, I would appreciate if you can type them in the chat.
So one of the questions was, what should one pursue after BTech? Like, should one get a job or go for higher studies?
Okay, that's a very interesting question because everyone goes through that dilemma. I was in your shoes too. I mean, long back. As a data scientist, I would like to answer this by saying you make more sound decisions if you have more data. How do you have more data? You have more data if you have more experiences, right? So do this when you're still when your undergrad is still going on. Start taking up research projects and start also taking up industry internships if you like get an opportunity, and then evaluate both, right? You would, if not in a year, maybe in 2 years, you would get familiar with what your actual passion is, and that is the only way to figure out. If not, if you're not if you don't have the resources right now, like you're not able to get the research internship or opportunity of your choice, well then all right, I think you should then maybe work in the industry for a year or two, try to get the job you like, right? And then if you think that you are more suited for research, like you find that more challenging, then you can always apply for a post-graduation degree, master's or PhD, and pursue that.
Another question from Uttam is, how should we begin our journey as to what kind of projects should we start with?
So you should, the purpose of this presentation was to make you familiar with what's most current in the industry and research both, right? So if you are interested in deep learning, data science, more specifically robotics, vision, or language, you should start from, I'll share this presentation. You should start from what all papers I've referenced. Start from those, start reading them. You will see what all information you lack. You will go back, you'll upskill yourself. You'll first read about, let's say we're talking about language generation. You would first read about how probabilistic models work, how masked language modeling works, right? How causal analysis works. That will take some time. And then maybe starting from these projects, you'll have to go back and then you'll come back at these. And then you can explore a lot of, I'll put in more references for generalized deep learning applications, and maybe you can look at those too.
There was another doubt about the prerequisites for starting in machine learning.
Some prerequisites which you cannot do without our knowledge of statistics. I could recommend some online courses run by Stanford, MIT, even UPenn, where I study, that can help you get up to the mark, at least, where you can understand how these algorithms work. You need to be familiar, or rather very fluent with Python programming, right? Knowledge of databases is not a hard yes, but it's, I think, and that's honestly easier to grasp. So I would say statistics and coding both. You would need some level of fluency in both these fields.
The next question is about deep learning, how to start with it, and what is its scope in neuroscience?
Neuroscience, there is very, very high scope in neuroscience. In fact, even in brain imaging, and how cognitive sciences is also a field that is catching up very fast with the application of deep learning. So, sorry, what was the first part?
How to start with data science,
How to
the
start
deep
with
learning. Yeah.
Start with the papers I post. Go to Kaggle, look up competitions. You can filter them out. If you want to do neuroscience, you can filter them out too, right? And then identify conferences, target them at least a year from now, because you're students, you're research students, and then choose an advisor, work with him or her to figure out, to formulate a problem. And that is exactly that is something that will, put you in place. And that's where you have started your deep learning journey.
Another question is that apart from consulting, which is a better industry to work as a data scientist?
It's everywhere. Even if you go to a retail company, Walmart, for example, they have their niche data science team. If you're working in a neuroscience, life sciences company, they would have their, if not, they will soon come up with their data science team. If you're working in Microsoft or Google, they're not consulting firms, but everybody is doing data science right now. Even airlines, they are hiring crazy. United Airlines, I think, was one of the pioneers to establish operational analytics for optimizing their airline schedules.
The next question was that nowadays is AI ML more research oriented or and less application based?
That's not true. I think it's both. Uh, okay. How do you define application based? It's more applied. See, if you are working to devise a new AI algorithm, like recently, I think 4 years back in 2017, transformers came into play. These are not the electrical transformers I'm talking about. These are those masked language models, BERT model, for instance. Researchers, they paired up with the industry and some universities to come up with a new AI model altogether that works differently. Now, that was completely theoretical, how that runs, right? Now, what people are doing is they're using that as an applied way to get their predictions or classifications or generate language. So you can work on both. It's up to you. Like if you want to go into more theoretical, and theoretical in AI will be math heavy. Yes, I think I see a question. Should we focus more on implementation or maths? If you want to build something out of it, like maybe you want to make your make some AI algorithm more robust, you will have to go back to the math. You will have to see how it works. And these algorithms are very math heavy. To be specific, a lot of linear algebra goes into it, matrices, right? So for that, if you want to do that, then yes. If you don't want to, like, if you want to use the existing models and do, let's say, social media analytics, right? You want to do analysis of depression study by just analyzing the conversations. You don't need to go back and create a model. There are models already there for you. You can just use them and get insights and then see if they make sense or not.
And lastly, one of the student had a doubt regarding the meaning of the modern no, no, no in the VQA slide.
Meaning of the, oh, okay. Right. There were three models that were being evaluated. That's why there are three responses: no, 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 and 112. And the human answer was no. So the question posed to the AI in this task was, does the cat look happy? Like if you see it, it doesn't look happy. I mean, the definition of happiness would mean when your the area around your lips goes slightly up, forms a U, right? That's how you would recognize it's a happy face. If it's an N, you could say it's an unhappy face. So that's how it realized that it wasn't happy. But if we put in some noise in the data, like that noise, you cannot see that noise, but it exists. It's like pixelating the image, right? If you do that, then you see that the models are not robust enough. And how many drawings are there on the cat's tie? The actual answer is 1, 2, 3, and 4, but the models give out some bizarre answer like just one. They're able to recognize only one. So they are evaluating three different models, and hence you see three different responses. Was that with
I
deep
guess
learning?
these
Well,
are
I
all
answered that
the
already. All right. Okay. I can wait like for another minute or two to see if there are more questions. And guys, like feel free to reach out to me on LinkedIn. I would be happy to assist you if you want any ideas on projects or how to pursue your post graduation. I can help you with that, and I will share the presentation with Mehak and Harshit, and you can reach out to them so that I'll try to add more research paper links in the end, right? You can go through that. Start reading, I would say. The more you read, the more you gather data, and the more familiar you become and more sound decisions you can take. Some platform or tutorial to learn basic ML. Yes, I'll add those at the end of the presentation. Don't worry. I'll add some links.
So thank you, Karan, for such an insightful and informative session. So your session has actually bridged the gap between virtual and in-person webinars, a major hardship we have been facing during the pandemic. And we hope that all participants also enjoyed being a part of it and the session embellished your expertise. So on behalf of the IEEE PEC student branch, I thank all those who took part in today's event and the audience for being so interactive and patient. So lastly, as a token of our appreciation due to the pandemic, we would like to present an e-token to you uh,
Oh, that's
for
great.
sharing your knowledge with us.
Wow.
So thank you for that.
Thanks a lot. I mean, honestly, I'm there for everyone who is willing to contribute to any kind of research or education, right? So feel free to reach out to me. Uh, I'm in fact very happy to be here to be speaking about this, and I'm trying to make you guys aware of something that is really, really hot and is in demand. So yeah, I mean, thank you so much, and I'll maybe see you guys on LinkedIn, and I'm gonna stop the recording, and maybe Meg, you can stay for 2 minutes after the call.
Sure. Also, we will be circulating a feedback form. So everyone is requested to fill that before they leave. It will be shared on the chat itself, the link.